Hello, welcome to Higher Ground Tutoring. This is Eric, and today we're going to do another lesson on solving systems of equations by elimination. This is going to be part 2. In part 1, we learned how to solve systems of equations by when the variables are lined up and they're easily canceled. Today we're going to learn a way to do it by having to multiply one of the equations by a constant in order to get the variables to cancel. So, can't remember exactly what our equation was, but I'm going to come up with a new one this time. It's going to be 3x, I think it was actually this one, 3x plus y is equal to 7. And then I think the other one was, I think it was 2x minus y. Actually, we're going to change this one around a little bit here. We're going to change the second equation to 2x, let's see here, minus, say, 3y is equal to, try to think of one where the variables cancel out easily once we multiply it through. And I'm going to say minus 10 here. I think that will work out. We'll find out. Anyway, so we have two equations here. This time, though, we don't have anything that will line up to cancel. So we have to multiply one of these equations by a constant. Well, if we multiply the top equation by 3, we can get the y's to cancel out. So that's what we're going to do. Okay, so we're going to take this equation and distribute it, multiply 3 by each one of the variables there. 3 times 3 is 9. It's 9x plus 3y is equal to 21. And then our other equation, I'm just going to keep that as normal. So now you can see we have the y's plus 3 and minus 3, so both cancel out. So we're going to add the equations together. So we're going to get 11x. These will cancel out. It's going to be equal to 11. 21 minus 10 is 11. So then we divide by 11. Divide by 11, so we get x is equal to 1. Okay. All right, so now we have so part of our answer is going to be 1 for the x value. Now we just have to find the y value. So we're going to take that 1 like we did last time and plug it into one of our equations. Again, I'm going to go with the one that has all positives. You could do either one. And the other equation we'll use to check it afterward. So take that 1 for the x and plug it into this equation here. So it's going to be 3 times the 1 plus y is equal to 7. So 3 times 1 is 3, plus y is equal to 7. And then we're going to subtract 3 on both sides to get the y alone. So then y is equal to 4. So our answer is going to be, graphs are going to intersect at 1, 4. At 1 for the x value and 1 for the y value, 4 for the y value. All right, so now what we're going to do is we're going to take the other equation. It's very important that you take the other equation. You don't want to take the one you just solved for, just in case you made an error. You might make that same error in this one, or it might work in this one. But in this case, since you solved for this one, you know it works in this one. So what we're going to do is we're going to put it into the other equation. And if it works for this one, I'm going to put both the x and y in it, and if we get a true statement, then we know that we solved it correctly. So 2 times 1 is 2. It's going to be minus 3 times 4 equal to minus 10. A little close to the edge here, but that's all right. We can read that, minus 10. Now we're going to take 2 times 1 is 2. Minus 3 times 4 is minus 12. So that's going to be equal to minus 10. And 2 minus 12 is minus 10. And minus 10 is equal to minus 10. So we get a true statement here. Minus 10 is equal to minus 10, so we know it works in this one. And if we check this one real quickly, 1 times 3 is 3. Plus that 4, 3 plus 4 is equal to 7. So it did work in the original one. But the only thing you really need to do is you need to check the answer in the equation that you did not use to find the other variable. And that's pretty much it. So that's how you solve simultaneous equations or systems of equations by elimination. Elimination. Let's spell that correctly. Elimination. And this is where you have to multiply the variable, one of the equations, by a constant. So I hope that helps. And we'll be back with part 3, where we need to, you might have to multiply both equations by a constant. Alright, so this has been Eric from Higher Ground Gaming, and we'll see you in the next video. Take care and God bless. Bye-bye now.